Hello, CCR scholars. This is Mr. Benzel here. And today we're going to be discussing skill 7, which is completing the square. So one thing that I think is important when we're talking about completing the square and the SAT is sort of being able to recognize completing the square. And with this, I have, if we are not going to be in class during the start of skill 7, this little meme with the office, and it says corporate needs you to find the differences between this picture and this picture. And you know, the lady says, me after learning completing the square, they're the same picture. So we need to kind of understand that the vertex form and the standard form are kind of related and just another way of writing them. So to kind of build up to the completing square, I'm going to kind of start with some solving quadratics, you know, kind of by brute force. So remember, when we have an x squared, if we want to actually get x instead of x squared, you want to make sure that you are square rooting, and you want to make sure that you are putting a plus and minus sign before the square root. So we're going to say that x is equal to plus or minus 8. So that means that x could be positive 8 or negative 8. So the next level above this one would be in something like b, where I have 4 times x squared. So I ask myself, what is the opposite of 4 times x squared? So the opposite of that is dividing by 4 instead. And when we do that, I'm going to get x squared equals to 196 divided by 4. So you could go actually to your calculator and do that. And we get that x squared is equal to 49. And if we want to get x, we do plus or minus the square root of 49. Which effectively is plus or minus 7. Now, you could have also solved this problem by doing a difference of 2 squares and factoring, and then taking each factor and setting it equal to 0. All right, and then C, this one we kind of have in kind of a quasi, almost vertex form. And notice here that I have these things in parentheses that are being squared. But if I want to undo the square, I can square root, and I want to make sure that I'm putting a plus or minus on the other side. So I have x plus 2 equals to plus 25, or x plus 2 equals to minus 25. Square root. Don't forget to square root on there and keep the square roots in there. So we have x plus 2 equals to 5, or x plus 2 equals to negative 5. So I'm going to subtract by both sides the 2. So I'm going to get x equals to 3 as one of my options. And then the other one, I'm going to get x equals to negative 7 as my other. And that concludes. Okay, so let's actually kind of look at a completing the square type of example. So this builds to our completing the square. So on 2a, this says each of the above equations were solved using the square root. So like our previous examples, can you square root x squared plus 24x plus 11 equals to 81 in its current form to solve? And the answer to that is actually no. So we're going to actually try to rewrite the equation so that we can square root. So to do this, we are going to complete a rectangular diagram to find the factors of x squared plus 24x plus 144, and then rewrite the equation with the factors. So when we do this, one thing that is very important is this, this b over 2 squared. And that gets us, this sort of completing the square. But one thing that we can do kind of immediately is we can kind of think about what is the square root of 144. And that's kind of equal to 12 in the positive form. So basically, if we were to factor this, I would have x plus 12 times x plus 12. And x times x is going to be x squared. And this is going to be 12x. And this is going to be a 12x as well. And then 12 times 12 is 144. And we're going to go ahead and we're actually going to solve this equation. So on this x squared plus 24x plus 144, we're going to write this as x plus 12 squared. And then on the other side, we're going to set this equal to 81. And then we will take the square root to get rid of this square on both sides. And when we do that, I get a plus or minus the square root of 81. So this is effectively x plus 12 equals to plus or minus 9. So what this effectively means is that x plus 12 equals to 9, or x plus 12 equals to negative 9. So if I'm actually solving these equations, I'm going to get x equals to negative 3, or x equals to negative 21. So this kind of builds into sort of a completing the square for the sake of solving. All right, so just a roadmap of completing the square. What you want to do is you want to move the constant away from the x terms and make sure that it is on its own side of the equation. Then you're going to be filling in the rectangle with the x squared and the x terms so that both factors are the same. And this is where we kind of do sort of that reverse box method. And then you want to add to both sides to the equation the value that is needed to complete the remaining square in the rectangular diagram. So this is always going to be the b over 2 squared. And we'll kind of see an adding example in a second or two. And then you want to write as a perfect square and solve. So you should have something squared equals to, some type of number. And we're going to take the square root of that something squared. And that's like the plus or minus the square root of that number. And then we just have, whatever is here equals to plus or minus that square root of that number. And you can actually get like the x or whatever you need all by itself. That's a little roadmap. All right, so we're going to kind of look at this first example here. So what we kind of notice here is that we have a square that needs to be completed. We are okay with step one. We have the constant on one side and then the x terms on the other side. So what I effectively need to do is add a number on both sides that is going to complete the square. And you might be asking, how do I get this number? Well, one thing that I'm going to do right off the bat, I know that x times x equals to x squared, and then half of negative 10x is minus 5x. So I want, it to be the same thing that adds to negative 10x. So, negative 5x and negative 5x happen to do that job. So I got an x here. So this means that this has to be negative 5 and this has to be negative 5 as well. And what we're going to kind of be doing here is thinking about what the number, and I'm going to make this blue, the number that we get when we do negative 5 times negative 5. And that number happens to be 25. So what completes the square on the right side is the number of 25. And then what we have, if we're adding 25 on one side, if we do not want to change the equation, we have to add 25 on the other side. And when we do that, what we are effectively getting when we do that is we are going to get 9 equals to, and notice that I'm going to be taking the factors. So I'm going to write this as x minus 5 squared because we have x minus 5 multiplied. So we got that. And then what we're going to do is we are going to take the square root so we can get, that x by itself eventually. So when I do that, I'm going to do the square root of x minus 5 squared equals to the square root of 9 plus or minus. And I'm going to have plus or minus 3 equals to x minus 5. So I have x minus 5 equals to 3. So that's one of my options. So I'm going to add 5 to both sides. So I'm going to get x equals to 8. And then I also have x minus 5 equals to negative 3. And I'm going to add 5 on both sides. So I'm going to get x equals 2 when I do that. Let's go and look at another example. So example 2, this is a situation where the constant is not on one side, but you want to move the constant on one side. So we can quickly remedy that problem by just putting 63 on the other side. So I'm going to write this as x squared plus 2x, and I'm going to add a little space because we are going to be adding something to both sides, and it's going to equal to 63. And we are going to be adding a number that's going to complete the square on both sides. So I'm just going to change my pen color and make like a blue square. And we're going to add that same number on the other side. And we're going to kind of work through what that number is going to be. So one thing that I do know is that when we factor x squared plus 2x plus whatever that mystery number is, the first term is going to be x in each factor. So that gives us our x squared. Our goal is to get 2x. And the way to do that evenly to get 2x is to say that we have 1x and 1x. So these are positive. So this is going to be a plus 1. And this is going to be a plus 1 as well. And the number that's going to be in blue, and this is the number that completes the square, is just going to be 1 times 1, which is just 1. So I'm going to add 1 on both sides. So I'm going to rewrite that. So because the factoring of x squared plus 2x plus 1 is x plus 1 times x plus 1, I'm going to say that that's going to be x plus 1 squared. And I'm going to set that equal to 64. And I'm going to square root both sides. And I'm kind of doing it in a different color just to make sure that it is, you can kind of see that square root process there. And when we do that, we get the x plus 1 out of the square root, and that's equal to plus or minus 8. And what this leads to is that either x plus 1 equals to 8 or x plus 1 equals to negative 8. And I'm going to subtract 1 on both sides. So I'm going to say that x is equal to 7. And then I'm going to subtract 1. And I'm going to say that x is equal to negative 9. And those are the two answer choices. We're going to do just one more, just so you can see. This would be a you try in class, but I do want to give you just one more for the shape and size. So on this one, we have a constant that we need to move to the other side. So I'm going to combine the 10 and the minus 5 to get 5. And that's equal to x squared minus 14x. And what I need to do is I need to kind of add that square number on both sides. So I'm going to put a plus whatever that number is going to be in the working out of our box. So when I do that, I know that x and x are going to get me x squared. And if I want to get minus 14, I'm going to do, minus 14 divided by 2, which is going to get me to negative 7. So if I did, negative 7x and negative 7x, I would have a minus 7 and a minus 7. And then the blue square number is just minus 7 times minus 7, which is going to be 49. And we have our factors. So the x minus 7 and the x minus 7. So we're going to effectively call the trinomial at the end of the day. We're going to call it x minus 7 squared. And we have 49 plus 5, so that's 54. And we're going to square root it and add a plus or minus. So I have x minus 7 equals to plus or minus root 54. And I'm just going to move the 7 over to the other side. So we're going to have x equals to 7 plus or minus the square root of 54. If you want kind of a general formula for the completing the square, just as a little pattern in your standard form polynomial, the ax squared plus bx plus c. We're going to be mainly focusing on like the a equals 1. But one thing that you can always do is that you're going to have like a b over 2. So this is going to be like your b over 2x. And this will be also your b over 2x. And this is going to be b squared over 4. Or we could also say like a b over 2 squared. And that's going to always be your magic box. So you could always just do your b over 2 squared. So let's actually take a look at that. On Delta Math, one of the things we're going to give you is just a simple time challenge. So it says find a value that completes the square. So the easy way to do is to actually just do b over 2 squared. And this is a negative 8 over 2 in parentheses squared. So it's going to be negative 4 squared. That's going to be 16. And like that, we're done. So the SAT is actually going to have you do things where you're actually looking pretty quickly and kind of recognizing what number is going to complete the square. Now, SAT problems. So an easy example would be like number 1. We can actually see that the constant is already on the right side. And I'm going to actually just write x squared minus 10x plus whatever number completes the square is equal to 75 plus whatever number completes the square as well. And it's asking us, what is the value of x plus 5? So one thing that is kind of a hint here that we have is we got the x squared minus 10x. So I have the x. And then b over 2 is just going to be minus 10 over 2, which is equal to negative 5. So that means that your factors are both, x minus 5 and x minus 5. And then the number that completes the square is going to be 25. So we're going to be adding 25 to both sides. And we're going to write this in factored form. So this trinomial is the same thing as x minus 5 squared. And that's equal to 100. And I'm just going to square root both sides. And remember to put a plus or minus with that 100. So I have x minus 5 equals to plus 10 or minus 10. So this means that x could be equal to 15. which if we look at the answer choices, they're all, negative or zero answer choices. So this thing may not really matter too much. Or we could actually go to the x minus 5 equals to negative 10. And we're going to add the 5 on both sides. So I'm going to have x equals to negative 5. And the question is going to be, what is the value of x plus 5? So I get negative 5 plus 5. So that's the x plus 5 equals to 0. And that would make D our final answer choice. Number 2 is a harder example. It's kind of more conceptual in nature. So you might want to kind of look at the conceptual example we did a minute ago. So on this one, it's still the same idea. We're going to be adding a magic box on both sides. And I'm going to kind of reason what that magic box is going to be. So I know that I have x squared and my b over 2 is just going to be negative k over 2. And it's going to get ugly, but there is something useful in the problem that will make it a lot less uglier. So I'm going to have a k over 2 and a minus k over 2. And then on this, I have a k over 2 squared. So when I do this and rewrite the problem, I'm going to have x squared minus k over 2. Oh, wait, actually just x minus k over 2. And that is all squared. And that's going to be equal to 20 plus k over 2 squared. One thing I know about x minus k over 2 is that this is equal to 6. So this is 6 squared. So that's going to be equal to 20 plus k over 2 squared. So that's what we added in our box. So that's going to get me to 36 equals to 20 plus k over 2 squared. So that means that 16 is equal to k over 2 squared. And when I do this, what's going to happen is I'm going to take the square root. So I'm going to have k over 2 equals to plus or minus square root of 16, which is square root of 4. I'm just going to kind of show that square rooting process as well. And we noticed that we have all positive, so we can kind of just focus on the positive case. So I have k over 2 equals to 4. So this means that K must equal to 8. Or on the other hand, we also have the K over 2 equals to negative 4 as well. So then we could say that K is equal to negative 8. So if I kind of look at this problem here, and let's say that I want to do X equals to, or X minus negative 8 over 2 equals to 6, I could say that this is effectively like X plus 4 equals to 6. So one of the values could actually be 2. So this is definitely going to be like a harder example, but I wanted to kind of go through this one just to show you what could be in, those more difficult completing the square. But something like number 1, I would say is a little bit more fair game of what you would see on the test.